Good afternoon, everyone, or wherever you are, or good morning or good evening, wherever you are around the world. I will eventually be part of this training. My name is Innocent Azi, Chief Operating Officer of Eco Carbon Exchange. We want to appreciate your availability to join us in this learning curve regarding climate change issues, especially with respect to carbon management. This is the concluding part of the earlier training that was initiated last week before we go into the second model. And want to believe that this knowledge is adding up in creating the appropriate awareness and education regarding the dynamics in the global campaign against carbon buildup in the atmosphere. You are welcome. I want to take this time out also to appreciate our resource person, Ms. Ngozi Eze, who is sharing with us her wealth of knowledge relating to this subject matter. I want to believe that what she's going to give to us today will build upon what we got last week. Thank you. Thank you, Mrs. for your expertise and readiness to share. We can now go ahead and take on the floor.
Thank you, Mr. Innocent. It's my pleasure to share my knowledge with you all on GHG management. So I'll go ahead and share my screen right now so that we can start. So this is a continuation of this module, Introduction to GHG Emission Dynamics, that we started last week. Last week, we took the Understanding Climate Change and the Principles. And today we are taking the GHG accounting, the principles of GHG accounting and reporting for corporate organizations. So today we are taking the part 2, elements of GHG accounting and reporting. And we have 3 parts to this part 2. That is GHG inventories. We are going to look at the meaning, the process of developing GHG inventories and their uses. And we are going to also look at the basic protocols for GHG inventories for organizational measuring, reporting, and verification. And then we're also going to look at the application of GHG management in business and other industries. So the same resources that we looked at, we got the materials from for the last week training. It's the same material that we are still using for the materials that we are still using for this week's training. So let's go ahead and look at the elements of GHG accounting and reporting for corporate organizations. So first of all, because what we are taking today is GHG accounting and reporting. So we want to look at the meaning of these 2 components of corporate GHG emission management. Both of them are not the same. When you hear GHG accounting, we are just talking about the process of an organization identifying and consolidating the sources of emissions from their operations. So when we are talking of consolidation, we are talking about the way that organizations identify the emission sources or operations that yield GHG emissions that they are responsible for. So that is what we mean by consolidation. And then we are linking these emissions that we are talking about to specific operations of that organization, specific sites, maybe production sites or geographic locations or their business processes, and then owners of those operations that we are looking at where the GHG emissions are coming from. For example, if you have an organization that has maybe IT, business unit, manufacturing, packaging, sales, and all those things, and then maybe your GAG inventory wants to cover the manufacturing section of that organization or the sales business unit, you have to identify these different sources of emissions and link them to the specific operations of that organization that you want to account their emissions for. Then the reporting part is just after you have finished identifying your sources and estimating the GAG emissions, when you present them in the format tailored to meet the needs of the uses of your inventory or the users, people that require those your inventory data, you present them in a format that will meet their needs or their expectations. This definition is according to the GAG protocol, corporate accounting and reporting standard. So what is a GAG inventory? A GAG inventory is simply an inventory of greenhouse gas sources. When you list all the greenhouse gas sources and sinks in your organizations and quantify them, to quantify the emissions or removals from the atmosphere for these specific sources and present them in that format that we spoke of. That is what we call GAG inventory. A GAG inventory is just a list of your GAG sources and sinks and the quantities of the various greenhouse gases that you are accounting for. So whenever you get GAG inventory, there are 4 parameters that characterizes it. It's not any report that you present that you will call a GAG inventory. So for any report that you're presenting to qualify as a standard GAG inventory, to meet the minimum standard of GAG inventories, you must have the emission or GAG emission removal, emissions or removal causing sectors. Let me take, for example, for an organization that is into manufacturing of cement, packaging, and then sales. Of course, you have maybe the administrative business units. So when you want to prepare a GAG inventory, you have to list all the business units or all the operation units or sites for that organization. So that is one of the minimum requirements for a report to qualify as a GAG inventory. The second one is the chemical or physical identity of the GAGs emitted or removed from the atmosphere, including their global warming potential. If you remember last week, we spoke about this global warming potential and what they are. So when you list your emission sources and say, my emissions are from the cement manufacturing unit, maybe the clinker preparation unit, packaging unit, you list all the greenhouse gases that you have identified that are emitted from those sources or sectors, and then the global warming potential of these greenhouse gases. And of course, the location of the emission or removal. Location is what I have already mentioned before. You say that this is from this facility of the company or from this business unit of the company. Then the last parameter is you must specify the time period you covered. So if your inventory is for the year 2018, just a single year inventory, you have to specify that this inventory, this emission or removal inventory is for 2018. If it is for a 5-year period, you have to specify maybe it is starting from 2015 to 2020. And then for each year, you have to specify this is the emission or removal for this year, the emission levels for each year, for each of the sources and greenhouse gases. So these are the 4 parameters that characterize a GAG inventory, standard GAG inventory. So what are the uses of a GAG inventory? I believe that last week when we were speaking, I spoke of climate scenarios or climate models. So greenhouse gas data serve as input to developing these climate models or scenarios, as as the case may be. So scientists, when they want to project what the climate will look like, what the temperature level will look like in the next 10 years, 100 years, 200 years, any number of years that they want to project into, they will need to impute data, GHG data, into climate models to generate the scenario of what it will be like. For example, if we continue emitting these levels, what we are doing right now, the levels of emissions all around the world, if it continues into the next 20 years, what would the temperature change look like? What would the regional temperature change, maybe in Africa, in Europe, what would it look like? So they just get GHG data, average GHG, all the total GHG data from around the world, and sum them up, and then use them to simulate a climate model to get the climate scenarios. So that is one primary use of GHG data. Then, of course, by the time they generate these climate scenarios that we are talking about, they are able to say this will be the impact of climate change on the world as a whole, or for certain regions, maybe for Africa, for Nigeria. They can now project and see that the temperature, the average temperature in Nigeria would increase from maybe an average of 28 degrees Celsius to like an average of 32 degrees Celsius in the next 100 years or in the next 50 years, given if we follow this emission pathway that we have right now. So by using this GHG data, they are able to develop this climate change scenario and then discover what will be, or establish what will be the impact of climate change on different regions of the world, and also identify opportunities to reduce emissions. So policymakers rely on GHG data to identify opportunities for reduction, because it is when you quantify your emission levels that you're able to say the highest emissions are coming from this activity or from this sector or from this business unit. So I have to, if I want to reduce my emissions, percent reduction. These are the sectors or business units that I have to work on. I'm sorry. So the second use of science to the government regulations on emission levels. Hello, can you hear me? Okay, I'll just go on. Okay, so the second use is to monitor compliance of organizations. For example, the government can come up with restriction or a cap on emission for certain industries or organizations and say, do not exceed this level of emissions from your operations from this year to that year, because we are trying to mitigate GHG emissions in the country. So how will the government know the organizations that are complying? It is by getting a report of their GHG inventory. By getting the report of their GHG inventory and then comparing it to their baseline or base year emissions to know whether they are complying to these regulations, these government regulations. And then, of course, if a company comes up with, let's say, a plan to reduce GHG emissions, how would you know that the measures that you are implementing, that they are working? It is when you get your GHG data for your base year. Your base year is like your reference year before you start implementing GHG reduction measures. Before you start implementing your GHG reduction measures, you get your base year GHG data and you keep it for comparison. When you start implementing those measures, those emission reduction measures, you compare your emission levels for those years when you have already started implementing your mitigation measures to your base year emissions to know whether the measures you are implementing is working or not. If they are not effective, then you may need to go back to the drawing board to find out why are our measures not effective. Do we need to increase effort, or is somebody doing something wrong somewhere? So these are the uses of GHG data. So basically, it is said that you cannot manage what you do not measure. So if you want to manage emissions from your organizations, you have to prepare or develop a GHG inventory before you can do that. Then the fourth use of GHG data is to participate in carbon markets. If you want to participate in carbon markets, how do you do that? Just when you implement mitigation measures, that is emission reduction measures in your organization, and you reduce your emissions, you have to quantify the reduction. So quantifying the reduction, how do you get the quantification? It is by conducting a GHG inventory on your, maybe the facility or your organization as a whole. So by the time you now quantify your emission reduction, you're able to say, these are what I got, the ERs, or certified emission reduction units from my efforts, and I want to sell them in the carbon market. So before you can participate in carbon market, you must develop GHG inventory, whether on organizational level or project level. So the next thing that we're going to look at is the process of developing a GHG emission inventory. You do not just jump in and start quantifying the emission reduction. You have to first of all plan what you want to do. So there is the planning stage, there is the development stage, and then before you get to the management stage. So during the planning stage, you see the activities that are there, assigning resources. We are going to look at the implications of these activities. So you assign resources, you design your inventory, you collect the necessary data, you calculate the emissions or reductions, and then you set targets for reducing your emissions. Then you implement the measures that you have planned to reduce your emissions, and then you report results. For the first year that you are developing your emission inventory, GHG emission inventory, you may not get to this certain target reducing emissions stage. It may just be to plan, develop, and then report. In the management section, is just to report your emissions. Then by the time you report your emissions, you will now start planning on how you will reduce the emissions in the next by the next time you develop your GHG inventory. So these terms that we looked at, the stages of developing a GHG inventory, what are the implications, what are the activities that are involved. So we have said that developing a GHG inventory involves 3 stages: planning, developing, and then the inventory management stage. So at the planning stage, you assign resources, as I mentioned. Assigning resources is just to talk to the management of the organization to get their approval, to get their support. And then, of course, identifying people who can work with you and establishing the team that will develop the inventory. Then, what data do you need? You identify the data that you need to develop your inventory. Which ones do you already have available? Which ones do you need to go and gather? By the time you find out, okay, we have, for example, the electricity used for 3 years for lighting and refrigeration, but we do not have the amount of or quantity of diesel that we use for our diesel generators, the ones that are owned by the organization. So you now plan on how you are going to get this data. Would you get it from within the organization, or would you go to the diesel supplier to get the quantity that they have been supplying you through the years? So that is what is involved in the planning stage. And of course, you will find out how you are going to gather the data that you need, because data gathering is very, very, in fact, it is resource consuming, it is resource intensive. Like You may spend money to get data, or even spend money to get additional staff to help you to gather the data that you need. Then the next one is to design your inventory. So what do you consider when you're designing your inventory? You have to consider the guiding principles and the business goals of the organization. What do they want to achieve? What is their priority? Is it that they want to reduce production costs? Is that why they want to develop an inventory, to find out ways that they can reduce costs, maybe energy costs, therefore reducing production costs? Or maybe they want to find out ways that they can improve the efficiency of their processes, thereby reducing production costs. So you define your inventory boundary. You define your inventory boundary. Inventory boundary is simply saying, these are the operational units that I am considering at this stage of my inventory development. These are the business units that I am considering. So those are the boundaries that you're talking about. Then you identify your emission sources and classify them as either direct or indirect. During the last class, we talked about these direct and indirect emission sources. So by the time you identify your emission sources and classify them, you will now find out which ones am I going to include in my inventory compulsorily. The direct sources, you must include them in your inventory. The indirect sources, scope 2 and 3, they are not compulsory to be added in your inventory, but it is advised to add them in your inventory. So I was talking about defining your inventory boundary. Defining your inventory boundary for organization does not have to do with, let's say, okay, we are taking Lagos zone, our companies in Lagos. No, the boundary is when you determine the operations and business units that are controlled by the company that is preparing the inventory, which will be included in the inventory. Depending on the approach that you take for consolidation, whether you take the equity share approach or you take the control approach. The equity share is just saying this company owns 50% shares in the operations from these this operating unit or from this business unit. Therefore, 50% of the emissions that are coming from that operations unit is accounted for by that company. Or maybe we have 60% share of the operations of these business units. So, or we have 50% ownership of these operations. Therefore, 50% of the emissions from these the business or from the operation is our own responsibility. So that is what we mean by defining the organizational boundary. The control approach is simply by saying, oh, we have financial control over the activities or over these business units or over this operational unit. Therefore, if we have 100% operational control, that means all the emissions that are coming out, let's say Dangote Group, there's Dangote Refinery, there's Dangote Cement, there's maybe if they have a flour mill, and then the operational, they have 100% operational control over the refinery. If they have 100% control, it means that they have the ability to introduce and implement operating policies at an operation, maybe that refinery. So if they have total control, and a company either has total control, operational control, or they don't have operational control. So if they are the ones controlling the policy-making process at that refinery, then all the emissions from that refinery is their responsibility when they are taking the operational control approach. But if they are taking the equity share approach, they can say, we own 40% share of this refinery. Other people, other shareholders, they own different shares of that refinery. Therefore, we are only accounting for 50% of whatever emissions that we estimate there. So that is the first step. You have to determine the share of your organization in the total emissions from the operations or from the business units. Then the second stage is for you to develop your inventory. Developing your inventory just means you collect the data that you need to quantify emissions, and then you calculate your emissions. So you will select the base year. I have explained what base year means. Many companies are using 1990 as their base year. That is maybe before they started implementing emission reduction measures. So they are using 1990. Your company can decide, we don't have data for 1990. We can have data. You have to show the trend of emissions from your organization before you started implementing the reduction measures, GHG reduction measures. So that is the purpose of selecting a good base year, an appropriate base year. And then for some GHG reporting programs, they may have a specific base year that they require people that are reporting to them to use as base year. So you design an effective data management system, how you will gather and how you will store data, and then you get the activity data. When we talk about activity data, we have talked about emission factor. Activity data is to say, if I am estimating emissions from using diesel to generate electricity for my organization or for my process units or for my business units, the activity data is simply the total quantity of diesel that I used in that year. That is the activity data. Let's say I used a total of 3,000 liters of diesel in the year 2005 to generate electricity for my company when there is no electricity from the grid. So your activity data is that quantity of fuel that you purchased or that you used, multiplied by the emission factor. You get your emissions from that activity. Then, of course, you calculate emissions, applying some tools and models, and then conduct quality assurance and quality control of your emission estimates. I wanted to show us one of the tools that you can apply to calculate emissions. That will be later when we are talking about the different protocols that are existing. Then the next thing is to manage your inventory. Managing inventory simply means that you are identifying emission reduction opportunities. If you are looking at diesel consumption for electricity generation, what could be the emission reduction opportunities for that? By the time you estimate all the emissions from your operations, from your business unit, you now start looking at ways that you can reduce the emissions. Ways to reduce the emission is simply to reduce the activity level. If I was using energy intensive or inefficient light bulbs or inefficient refrigerators, I switch from those things to efficient refrigerators, efficient light bulbs, thereby saving energy. By the time you save energy, you are reducing emissions. So that is one way of, or let me say, one emission reduction opportunity that an organization can identify, like energy efficiency measures, whether in your processes or in your offices. Then you set your target. Target is just saying, from my emission level, if I was emitting 200,000 tons of carbon dioxide equivalent in the year 2015, I want to reduce this emission by 50% by the year 2030. I want it to be that by the year 2030, by implementing emission reduction measures, the emissions from my organization will be reduced by 50%. So that one is called absolute emission reduction. When you are looking at the overall emission level and saying you want to reduce it by X percent, 15%, 5%, 20%, as the case may be. Then you have the intensity target types. Intensity target type is by saying if emission per product, for example, I was talking about cement production. If I am using if I was emitting 3,000 tons, that is too much anyway. For example, if I'm emitting like 15 tons of CO2 equivalent per kg of cement produced, I can say that by implementing some efficiency measures, maybe in my process unit or in the energy use, I want to reduce the emission intensity to 3 tons of CO2 equivalent per kg in the next 10 years. So that is setting an intensity target. So intensity target is just setting the intensity based on the quantity of products or per square meter of the office space. You want to reduce emission or you want to reduce energy use by that amount. So that is setting target. Then you implement your emission reduction activities, or you can use carbon offset. Then you report your inventory information. So that is it about the process of developing an emission, GHG emission inventory. So the next thing that we are going to look at is the basic protocols and standards for organizational greenhouse gas accounting. The first one is the greenhouse gas, the greenhouse gas protocol corporate standard for GHG accounting. So a protocol is simply a set of common standards and calculation tools that you apply to measure and report your corporate GHG emissions. Then for GHG inventories, for you, if you want to develop consistent and reliable information, because company A cannot be using any kind of methodology or calculation tool or standard they like, maybe they developed it by themselves, and then the next one is using another thing. You cannot compare the information you are getting from using self-developed standards or self-developed. You can develop calculation tools, but if you are developing them, let them be according to set standards. So a GHG protocol takes care of this to make sure that there is consistency, and then that the information that we are reporting in our inventory, that they are reliable. Somebody can use them with confidence or a high confidence level. So the gold standard for corporate GHG inventory preparation is the GHG protocol corporate standard. It is a versatile reporting standard. You can use it for every GHG reporting, for almost all the GHG emission reporting program in the world. This GHG protocol corporate standard is adequate or suitable for most of them. So this standard forms the basis for the ISO 14064 part 1. That's the ISO that is applied for corporate GHG accounting and reporting. So if you want to get this corporate standard, you can download it from the GHG protocol website given. You can see it in this slide. So the next one is the one I just mentioned, the ISO 14064 part 1. That is also mutually compatible with the GHG. You can use it together with the GHG corporate standard, the protocol corporate standard. You can use both of them together. They are compatible. They are highly compatible. So these two standards, these two corporate emission reporting, accounting and reporting standards are based on the IPCC methodologies and industry best practice. The last lesson I spoke about the IPCC, like they are the #1 organization when it comes to giving information and the latest from science, from researchers around the world on climate change. So if you want to quantify emissions or removals for your organization, get these two tools. They are very, very good. In fact, I don't think there's any GHG registry and program that you want to report to your organization for that they will not be. I've not seen one anyway that they will not be suitable for. Then of course there's this climate registry general reporting protocol. You can check it from the climate registry website. And then there are other sector specific protocols. There's the one for the petroleum industry. There's the one for the Iron and Steel Institute. Your organization may have their own specific greenhouse gas accounting and reporting protocols and standards. So you just research and get them. But if you cannot find it, you can rely on these two that I have already given. That is the greenhouse gas protocol corporate standard and then the ISO standard. So for GHG accounting for organizations, the basic principle, they must meet these standards. They must be relevant. Your GHG inventory must be relevant. Being relevant means that you can, if I need my GHG inventory, your GHG inventory to identify emission reduction measures, you must prepare it in such a way or in a disaggregated form to help me to identify the sectors or the sources of emission where I can implement reduction. Not just for you to lump everything up and present it. So it must be relevant. It must meet the objectives or the business needs of the organization or the people who need the inventory. If the federal government of Nigeria says they want to get GHG inventory or GHG data from your organization so that they will find out the emissions from the use of diesel in your organization, then you have to prepare your inventory to meet that need. That means you do not just lump everything up. You have to specify the different fuels or different sources of energy that results in emissions from your organization, and then quantify the emissions from those fuels or sources of energy and present it in such a way that they can identify the emissions that are from each fuel. So that is what we mean by relevance. Then it must be complete. You have to ensure that all the relevant emission sources, for example, I mentioned that direct emissions must be reported. So at least at the barest minimum, ensure that all the direct emission sources are included. Then you can say, okay, my inventory is complete to a certain level. Then you provide justification for any exclusion. If I am not able to quantify emissions from an activity or from a source, maybe because of lack of data, I didn't have activity data, or because I don't have the should I say, the knowledge or the methodology to quantify the emissions, you have to specify clearly that I could not estimate emissions from this activity because there was no data, or because we don't have the capacity, technical capacity to estimate emissions. And then these are the ways that we are planning to ensure that the next inventory we produce, we will have that information there. Then you must be consistent. Your inventory must be consistent. That is to say that if you use a certain methodology this year, you must use that same methodology the next year. Otherwise, the one you estimated the previous year, you will implement the new methodology you want to use for the current year. That is one way to define consistency. Then, of course, the sources of data, you have to, as much as possible, make sure that the sources of data are from the same source, or your data are from the same source for each of the years. If you do not get, for example, from my experience, if you get data on petroleum, on the petroleum and gas industry from DPR, and you get the same data from NNPC, there are some inconsistencies, like you will not get exactly the same data or the same information from these two organizations. So it would be good that if I am estimating emissions based on data from DPR, I have to ensure that all the years that I am estimating emissions, I get my data from them. Otherwise, your estimations may not be consistent. So the next one is transparency. Transparency is just that the data you used, the sources, the methodologies or tools that you applied, and any underlying assumptions, you explain them in your report. Clearly give sufficient information that somebody that was not part of the inventory preparation team can say that, okay, understand how you got your result. The next thing is accuracy. Accuracy is simply ensuring that there are neither over or underestimates as far as can be judged. That is to say, you did not overestimate your emissions, or you did not underestimate it as far as can be judged. So ensure as much as possible that your estimations are accurate. So these 5 principles are what you should be looking at when you are estimating or you're developing your greenhouse gas inventory. So how do you apply greenhouse gas management in business and industries for corporate organizations? So why do you even need to develop a greenhouse gas inventory? Why do you need to manage their emissions? Why bother? Why spend resources to develop and manage your greenhouse gas inventory and emissions? First of all, It is very important for tracking, for verifying, and for achieving corporate social responsibility goals. For example, your organization may have social responsibility goals that are related to the environment or to GHG emissions, or you have energy reduction related goals. The GHG inventory will help you to track whether you are doing well or you are not doing well, or whether you need to do more in order to meet those your goals. Then, of course, you can identify the waste and cost reduction opportunities. I have mentioned energy efficiency measures to reduce emissions. How do you do that? It is by reducing the energy use. When you reduce the energy use, you are reducing emission. And when you are reducing your energy use, you are saving costs. You are reducing waste. So that is one way that organizations can use their GHG management is applicable to organizations. Then, of course, to benchmark performance and identify opportunities to improve competitiveness. For example, I manufacture, I'm just using manufacturing organizations, industries. It can be for any other organization that maybe our business unit, we are doing the same thing, the same process, the same business that this next organization is doing. And their emission is, let's say, 50,000 tons of CO2 per year. And our own is 100,000 CO2 tons of CO2 equivalent per year. Then it means that there's something that we're not doing wrong. So what you need to do is to look at your emission levels and then find out why is it that this organization, they are doing better. If they are doing better in their GHG emissions than us, meanwhile, we are manufacturing the same quantity. If they are manufacturing 100,000 or 1 million tons of maybe a petrochemical product, we are also manufacturing the same, but their emission levels are lower. It means that we are not doing something right. We are doing something wrong. And it means that we are wasting money. We may be wasting money, we may be wasting resources. So it is a way to benchmark performance and then identify opportunities to improve your competitiveness. Also, companies could encourage innovation of new products and services. For example, I heard of a company that manufactures tire as in for trucks and other vehicles. So in their quest to reduce emissions, they came up with a new kind of tire that the amount of energy used in manufacturing it is like very low compared to the conventional tires, truck tires that are out there. And then it's not just that the energy that they use to manufacture those tires. There are some ways that those tires are better, than the existing ones. So they want to know, hey, what is it about this tire? I want to get one, and all that. So it helps a company to gain first mover advantage. Like we are the first to do this in our industry. We are first to implement this. By the time you publish that in your company report or in your website, people now gain interest, even around the world. They want to know about that company, that we heard that this company is the first to implement this measure, or the first to do this, or to come up with this innovation in our industry, in Africa, or in the whole world. So it is a good thing for organizations to look at how to manage their greenhouse gas emissions. And of course, I have also mentioned participating in carbon markets. Organizations can identify projects that reduce GHG emission, implement them, estimate the emission reduction from these projects, and then sell their certified emission reduction units in the carbon market and make money. So sometimes the money you make from selling your emission reduction unit can even offset the cost of implementing the measure, maybe obtaining new technologies. Sometimes the savings from saving energy, like the money that you save when you are saving the energy, will even offset any money that you use, whether to develop your GHG inventory or to purchase new technology or to implement the mitigation measures. So most times the emission, because when you are planning the emission reduction measures, you have to look at the cost and the benefits. So most times the benefit, whether a monetary measure, offsets whatever costs an organization to implement emission reduction measures. And then there's this, if you want to participate in in GHG reporting programs, you have to develop a GHG inventory. And of course, with assessing liabilities and preparing for future greenhouse gas policies. I have mentioned that in the last class that in Europe, certain manufacturing industries, there's a cap or a limit to the amount or the quantity of greenhouse gases that they can emit per year. So those organizations, they have to implement emission reductions. So for Nigeria right now, those kind of limits or policies for industries are not yet in existence. But by the next 10, 15 to 20 years, the government will definitely come up with such policies, even as countries around the world are pursuing these Paris to achievement of the Paris Agreement. So for your organization to prepare, to be ready for such policies, first of all, start identifying your emissions and quantifying them, so that by the time the government is coming up with such policies, you are able to be already ready. You'll be waiting for the government. You have identified your emission reduction measures, and maybe you're already implementing some of them. So the Carbon Disclosure Project, if you go to their website, you will discover that they have information on the greenhouse gas inventory of over 2,000 companies from around the world, and then the emission reduction measures that they have been implementing. So you can check that up in your free time. So this is the additional references for these lesson notes. So you can look them up in your own time. Thank you. Any questions? Any questions?
Thank you very much. That was a great one. Please, can we ask questions? And our speaker, if I understand some questions were on platform in the last event, and that you may not have addressed. So you may want to also address them if that's possible. Now I hear you. I hear you that we can design our own methodology of assessment of carbon reduction besides what ISO and what the GHG protocol already has.
Okay. Okay, I saw a question. I think the question from is it Gaurav and the one that you're asking right now, they are similar. So maybe you came late. I mentioned the greenhouse gas protocol, corporate standard for GHG accounting. If you go to GHG protocol website, you will see the accounting tool. I am going to project it right now so that you will see what it looks like for tracking emissions. So tracking emissions, first of all, you have to develop your base year before you now start talking about tracking to know whether the measures you're implementing are working. So I am going to show you the tool, what it looks like. It's basically an Excel sheet.
Yeah, I'm actually asking that, you know, what we have also done is to find a hybrid of the two, especially where they mix and they are domesticable within our own operational boundaries. You know, so, and we've also understood from operators, auditors in Netherlands, that you can actually develop, you know, local ones that are, you know, easily, that could be verifiable as well. That is also meant for it. So the Eco-Carbon Exchange weighed all these ones, and that is what we are actually implementing. And I think, you know, your presentation has validated those approaches for us.
Okay, so I just want to show from, if we are talking, if I get you correctly, you are asking if you can develop your own tool for quantifying emissions, adapt it to the activities within your organizational boundary.
Yes, or the local economy.
Okay, exactly. So the basic standard, or let me say basic guideline or guidance for developing any emission inventory estimation tool that you want to do is the IPCC guideline for GHG inventory. So what it is when you want to estimate emissions, it is just multiplying your activity level or the level of activity by the emission factor. The emission factors, they are standard. You can also develop emission factors for your country or for your specific organization and say, this is the type of technology that we are using here. This is the emission per kilogram of activity. So, but if you do not have that, you can use the default emission factor. So all you need to do is, it's basically all these tools are spreadsheet tools. So you can use Excel and develop your own spreadsheet for estimating emissions. So I don't know if you can see my screen right now.
Yeah, we can see it.
Okay, so if you can see my screen, let's say for an organization, this is the tool, the person that asked me the tools for tracking emissions. This is the tool from this GHG protocol, greenhouse gas protocol that I spoke of. This is a tool that they developed. This one is for stationary combustion. So you can see here, the data required is the fuel type that you're looking at. Are you looking at electricity? Are you looking at maybe diesel? Are you looking at petrol? Are you looking at natural gas? You have to specify that type of fuel. Fuel usage, what is the quantity that you used per, let's say per year or for unit activity? You can say I use X number or X liter of PMS in my generators per hour or per year. So when you get that, then you now get what is the unit of usage, whether you're using volume or weight. So if you select that you're using volume or weight here, let's say for the year facility ID I and the year 2019, and then are you using custom emission factors? Did you develop your own emission factor? I will say no, that I want to use the default emission factor in this spreadsheet. But if you have developed for that organization, just as you're saying, or you have developed for that country, then you can say yes and impute the emission factor that you have developed. Then what is the fuel type? You select the fuel type. Am I talking about coal? Is that what you are using in your process unit? Or are you talking about crude oil? Or you're talking about butane? Which one are you talking about? Let me check. There's kerosene. Let me just use kerosene, for example. Or LPG. Let me use LPG, for example. What is the amount of the fuel? You can key in any amount that you used. This one is 10. I think this 10 is million BTU. Or I can increase it because I want to say that this is the total quantity of fuel I used in the year. So I can increase it. I can increase it to, let's say, 50,000. And I can change this my unit to say this is 50,000 kg. But if it is electricity, you have to use kilowatt hour. So I can change it to any unit I like. I can change it to gigajoule. I can change it to megajoule or any unit my data comes in. If your data does not come in any of these units, all you need to do is convert it. You get conversion factors from the internet. You convert it. And then you can see already that this spreadsheet has already estimated the emissions from the use of LPG for that year for my organization. So if it is, for example, electricity use that we are talking about, and I choose electricity, let me look for electricity. If it is emissions from the use of electricity, for example, you mentioned developing this tool for Africa. This tool now that you're seeing, this protocol you're seeing is for Europe, USA, I don't know the other country that they considered. They didn't consider African countries. So the emission factor for grid emission factor for Africa will be different from what they have in this tool. So if you want to do it for Nigeria, you need to adapt this tool or develop your own spreadsheet. It is not difficult once you understand the principle behind what they did here. What they just did for this CO2 emission is that they multiplied the total amount of fuel multiplied by the emission factor that they have put in one of the sheets in this Excel document. So if you have your own, you wire it. If I have it somewhere else, I will say, okay, this is my emission factor that I'm using. In this place, I'll wire it and say, this place will now be amount of fuel multiplied by my own specific emission factor that I developed, or the emission factor for Nigeria or for Africa at worst. Then you get your emissions of CO2. Likewise, all these ones. So the CO2 equivalent, I explained it in the last class, that what I gave an exercise on getting CO2 equivalent for these greenhouse gases. I said for you to get CO2 equivalent is just this, the emissions from CO2 multiplied by 1, that is the global warming potential of carbon dioxide, plus the emissions of methane multiplied by the global warming potential of methane, plus emissions of nitrous oxide multiplied by the global warming potential of nitrous oxide. You will get your total emissions for that year. So that is how to use this tool. If you want to develop your own tool, that is also a very good idea. You develop it, basically, if I am doing my own estimations, I develop my own spreadsheet. If I am doing it for maybe an organization or for a process unit or maybe project level. But if I am doing it for the country, maybe for Nigeria or for a region, an entire region in Nigeria, I tend to rely on the IPCC greenhouse gas inventory estimation tool. That one is also free. It's a free resource on the internet. You get it. You get the driver, what do you call it again? The software. You download it. You install it on your system, and you start doing your estimation. So, but all these things are just spreadsheet tools that somebody sat down and developed. So yes, you can develop your own spreadsheet tool, but making sure this link, yes, I think maybe they will share it with you.